Okay, this is the last sort that we're going to explore, and this one is called quicksort. So named because it sorts a array of data very quickly. So I'm going to give you sort of my toy array example, 50, 30, 60, 40, 20. And the big idea behind quicksort is how can we reduce the size of the array that we need to sort, like really quickly. And this kind of touches on a big idea that came up with binary search, and it came up a little bit with merge sort. And that's the idea of similar subproblems. Basically just reducing a problem we have to a smaller problem that is on the same footing as the original problem. And so that in that way, because the smaller problem's on the same footing, we can apply whatever technique we use to get the original problem to break down the original problem to the smaller problems themselves. So I think this will be a little bit of a interesting example because quicksort, in quicksort, you will pick something called a pivot. And pivot is kind of just an arbitrary element. So I just chose the element in the middle of the array, which is 60. And the point is that if we choose an element like 60, we can use that element to divide the array into two different categories. Everything that's greater than the pivot, everything that's less than the pivot. So I would probably do this by making a copy of an array. There might be a way to do it in place, but right now I only see I would do it with a brand new array, and I would put 50 less than 60, so I'd move it down. 30 less than 60, so I'd move it down. 60, we'll say less than or equal to 60, so we'll put it on the right-hand side. So like on the right-hand side of the array counting down, and then on the left-hand side counting down, so they sort of meet in the middle. 40 less than 60, so put it there. 20 less than 60, so put it there. And so everything on the left-hand side is going to be less than 60. Thing on the right-hand side greater than or equal to 60. And it just so happens, and this can happen in quicksort, that we chose a pivot that was exactly what we did to not really do that much. Our lists are not about half the size. We made a list that only has one element, and the other list has all the other elements. That can happen sometimes. But what's nice is because this is a list of element one, we know this is sorted now. And on an unsorted list, we can actually recursively apply this idea. So now I'm gonna pick, maybe since it's an even size, maybe I'll choose the middle. Pivot equals 30, like the middle two elements, and take the average. And the reason why I'm getting the pivot in different ways is because how you choose the pivot in quicksort is kind of like it's a big area of research. There's a lot of different ways to do it. As you can see, just choosing one element can have dire consequences. Some people will take 3 elements at random and take the average. That's why I'm sort of showing you the average method here, the averaging method. And so, yeah, now we have our pivot is 35, and we can apply that to this list here. 50 is greater than 35, so we will put it on this side of the array. 30 is less than 35, so we'll put it on this side. 40 greater than 35, so we'll put it over here. 20 less than 35, so we'll put it over here. And now we have these two arrays, which have the property, and this is also true of at this level, at both of these levels, the arrays that we have created have the following property. Everything on the right-hand side is greater than everything on the left-hand side. So if we sort both arrays independently, we've actually sorted the whole array. But we've reduced the size of the array we need to sort by half in each case. And that's sort of where the name divide and conquer comes from, because we're dividing the list sorting them individually, and that actually means that we've sorted the whole list. So 3520, well, I think we'll do the average method again, just to make our lives easy. So 25 and 45. And then that'll get us a list of 20, of 30, of 40, of 50, and 60 was sorted. Huh. And would you look at that? We sorted the list 20, 30, 40, 50, 60. So how did that happen? Why didn't we have to merge anything back together? It's a great question. It's because if you have a whole bunch of data, what's happening is we're breaking the data into different parts. Basically, we're dividing the data. So it's like I said earlier, if we sort all the data on the right-hand side and all the data on the left-hand side, they're going to maintain their property, which is that all the data on the left-hand side is greater than all the data on the right-hand side. So we can sort of repeat that, and we will very slowly approach this sort of smooth, the smoothness. I don't know, the increasing sequence of numbers that we so desire. I would say Quicksort's really fun to implement. I don't know why I'm blanking on it, but whether or not you need a new array is something you should play around with. Because right now, these would all be in individual arrays, but we obviously want to return a result in the original array that we sent in. So that's something to think about when implementing Quicksort. Another pointer is that you can implement Quicksort with like 3 lines of code if you use recursion. So, recursion is nice sometimes, even if it breaks your brain, I guess. But good luck and have fun.